Okay, so now that we understand how to use the discriminant to find how many solutions we have, now we're going to use the quadratic formula to actually find those solutions. So the quadratic formula tells us the actual solutions for a quadratic, or for a function. It tells us the x-intercepts, whereas the discriminant just tells us how many x-intercepts it might have. Before we get into that, I just want to review what we've learned so far about the two methods that we've learned. So we've learned two different ways. We've learned just using a graph and factor. Factoring is pretty convenient when it is factorable, and graphing is pretty convenient when the graph is provided, but that is not always the case, which is why we need the quadratic formula. So on number one, that is factorable. So I can jump straight to my factors. I know that 10 times 1 adds up to 10 and multiplies, 10 times 1 multiplies to be 10 and adds up, 10 and 1 adds up to be 11. So I know that those are my two factors, x plus 10 and x plus 1. And then I want to think about what's going to make those two factors equal to 0. How do I make that factor and that factor equal to 0? Well, these two, it's basically just the opposite sign here. A negative 1 would make that factor equal to 0, whereas a negative 10 would make that factor equal to 0. So my two solutions, or my solution set, is negative 10 and negative 1. From a graph, it's maybe even more intuitive. Just from that graph, you can see the x-intercepts. It's wherever my line, or my curve, really, hits the x-axis. So my solution set there is negative 5 and negative 1. In addition to zeros, we can also call these x-intercepts roots or solutions. All of those really mean the exact same thing. So I just want to talk about really the pros and cons of those two methods of graphing. So in our original notes, we really talked about graphing as our first method, and we talked about factoring as our second. So if those are available, we do want to use them, but sometimes they are not, which is why we have to use a quadratic formula. So graphing is very easy if we're given the graph. It's visual. I think it's the most intuitive. You just see the x-intercepts right on the graph. But it's also hard if you're not given the graph, because then you'd have to plot a bunch of points. You don't know really where it's going to hit the x-axis, so you just have to start plotting points until it starts hitting the x-axis, and it's not always going to work. Sometimes it's going to hit at a decimal, and it's really tough to tell what that decimal point might be. Factoring is faster than the quadratic formula. It's also faster than graphing by hand. It's intuitive in that we set one factor equal to 0, and if one of the factors equals 0, then the whole thing equals 0. I think it's mathematically intuitive. If you understand what you're finding with that solution, when you set one factor equal to 0, you're really thinking about making the entire thing equal to 0. But it doesn't always work. It does not work for prime functions, prime quadratics, which is exactly what's leading into method 3. This must be used for prime quadratic equations that cannot be factored. When I say that they're prime, I'm basically saying that I'm going to get irrational solutions. It can be used for any quadratic equation. That's a huge positive of the quadratic function, or quadratic formula. It can always be used. So if you're not sure how to factor something, if you can't figure it out, you can always back up to the quadratic formula and use that. It must be in standard form. Which is what that is showing. Ax squared plus bx plus c, where basically it's just in descending exponent order. It starts out with the x squared, and then the x, and then no x at all in that third term. So it's also on your formula sheet. You don't have to memorize any sort of factoring steps. You can just use that from your formula sheet. It looks confusing on your formula sheet. Actually, sorry, this should say a does not equal 0. Because the number on the bottom cannot be 0, otherwise we're divided by 0, and that doesn't work. So that's the formula you have on your formula sheet. The most confusing part may be this plus minus sign. You might not have ever seen something like that before. What that's really saying is that we're going to do two different operations. We're going to add and we're going to subtract, and I'll show you that in our examples. So we want to use the quadratic formula. Even if I'm able to factor these, I still want to use the quadratic formula. So it needs to be in standard form. Right now that is not in standard form. What it really should look like is ax squared plus bx plus c equals 0. So I have to have everything on one side and 0 on the other side, so that 2x is a problem right now. So I'm going to minus 2x on both sides. And I'm going to put it where it's supposed to go. I'm going to put that right in the middle. It's x squared minus 2x minus 8 equals 0. Now I have standard form. So I'm going to plug into my equation, just so we remember what it is. It's x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So before I actually dive into plugging those numbers in, I'm just going to label my variables. A is 1. B is negative 2. And C is negative 8. So I'm going to substitute all of those in for that equation. Negative b, or negative negative 2, plus or minus the square root of b squared minus 4ac, all divided by 2a. Hopefully you have enough room. I'm going to run out of room really quickly here, so actually I'm not really going to rewrite that whole thing. I'm just going to substitute numbers in once I do that operation. So I need to follow order of operations. So I'm really thinking about PEMDAS here. I'm thinking about, or GEMDAS really, because I have a grouping symbol of that square root. That's really where I'm going to start. I'm going to start on top of that fraction, inside these square roots. I'm going to do this operation first. Negative 2 squared would give me 4. I'm still going to work inside that grouping symbol. My next step is multiplying. Actually, I have to finish everything inside of there before I do anything. I have to solve the discriminant before I do anything else. So now I'm going to do negative 4 times 1 times negative 8. That would give me a positive 32. And I really want to think about that sign carefully. If I get a positive 32, I'm going to write that exactly like I'm saying it, as a plus 32. And I have one more step inside of there. I'm going to finish that by adding those two together, which would give me 36, which is pretty convenient because that is a perfect square. I think I can fit the rest of this here by writing it. So this equals negative 2 plus or minus 6. So I finished everything inside of the square root symbol, and then I did the square root of that number. I actually got 6 from the square root of 36. I'm going to finish a couple other things before I deal with that plus and minus symbol. A negative 2 is really just the same thing as a positive 2. And 2 times 1 on the bottom is really also just the same thing, a positive 2. All right, so now I simplified everything except for that tricky plus and minus symbol. What that's really saying is that I'm going to split this into 2 separate problems. So, actually, I think I am going to need a little bit more room. Let me just erase some stuff. This is telling me to split that into two separate problems and do those two different operations. I'm adding and I'm subtracting that 6. So I'm going to do 2 plus 6 divided by 2 and 2 minus 6 divided by 2. These are going to give me my two solutions. They happen to be rational solutions. 2 plus 6 is 8. Divided by 2 gives me my first solution of 4. And 2 minus 6 gives me negative 2. Divided by 2 is negative 2. Those are my two solutions using the quadratic formula. I can also take those and plug them back in and make sure that they're actually making this equation true. So I would take 4 and plug it in for both those x's, make sure that equation's true, and then take negative 2 and plug it in for both those x's and make sure the equation's true. You can always check it by plugging your answers back in. That was a lot of steps, but it does get a lot quicker over time. So again, I'm going to set this up very slowly, but it will get quicker. As you practice this more, you start simplifying parts that you know are going to simplify easily. For example, the bottom can always be simplified in that first step. That's what I'm going to do in the first step also. Before we do that, label everything. My A is 1, B is 12, and the C is 36. So let's use a different color. Let's dark green. Negative B plus or minus the square root of B squared minus 4AC all divided by 2A. So really, on the previous example, I said do everything inside of the square root symbol first, do the discriminant first, and that's true. Order operations does suggest that we do that, but actually that fraction bar is really a grouping symbol. It's grouping the top and the bottom. So I know those are going to be completely separate until I actually do the division. So that's what I'm going to do. I'm going to actually do the top and the bottom at the same time. Negative 12 plus or minus the square root of, I'm going to do everything inside of here. 12 squared would give me 144, minus 4 times 1 times 36 is also 144. So that would give me 0 inside the square root. I'm also going to simplify the bottom. That just turns into 2. This is one of the examples where we only have one solution. So I am going to split this up into two separate problems. Negative 12 plus the square root of 0 is just 0, all divided by 2. And negative 12 minus the square root of 0 is still 0, divided by 2. This is why it comes together and just makes one solution. Those are both the exact same thing. They're negative 12 divided by 2, or negative 6. If I add 0 or subtract 0, it's the same thing. So it just gives me the one number on top, which happens to be negative 12. That gives me my final one solution of negative 6. So on a graph, this would hit negative 6 on the x-axis and then bounce off and continue going up in the opposite direction. It just hits the x-axis the one time. All right, on number 3, we are already in standard form, so all I really need to do is plug those numbers in. You could factor out a greatest common factor if you really want to, and actually make these numbers smaller, but I'm going to plug it in as is just to show you that it works on any quadratic. You don't have to think about factoring at all. You could just plug in your A of 5, your B of 5, and your C of negative 60. Sorry, that was a negative 5 for B. So I'm going to take each of those and plug them in. to negative b. This is another change I'm going to make. I know that this is going to be in front of my formula. I have a negative b, and b is a -5. I'm going to change that into a +5, just so I don't have to write a whole nother step just to change that sign. So I'm going to change that into a +5 plus or minus the square root of -5 squared, or b squared, minus 4ac. All divided by 2a. So I'm going to do stuff on top and stuff on the bottom at the same time. Everything inside my square root symbol, which is 25 minus, well, actually, sorry, that is going to turn into a plus sign. I have -4 times 5 times 60, which gives me 1,200. So that's my discriminant, 1,225. So this changes into 5 plus or minus the square root of 1,225 divided by 10. I'm also going to simplify that. 2 times 5 into 10. So my next step is doing the square root of that 1,225, which is 35. So when I see that I got a perfect square, 1,225, which gave me a nice whole number of 35, that tells me that I actually could have factored this in the beginning. But this is going to work either way. The quadratic formula will always work. If you don't see factoring or just don't like factoring, you can always use the quadratic formula. Now I'm going to split this into my 2 problems. Let's use that for the plus sign, and let's go with orange for the minus sign. It splits into 2 problems because that's what that plus minus symbol really means, that I'm actually going to do both of those. I can add and I can subtract from that +5. So that would give me 40 divided by 10 over 4. This would give me -30 divided by 10 or -3. And those are my 2 solutions. 4 and -3 makes my solution set. All right, number 4 is not in standard form, so I have to rearrange that. I have to get everything on one side. I just happen to like having everything on the left side. It really doesn't matter, but it's also going to keep my front numbers as a positive, so I also like that. I'm going to subtract this, excuse me, the entire thing in one step. Actually, no, I'm not. I'm going to subtract that in 2 steps. I'm going to minus the 8b from both sides. That would give me 9b squared minus 8b equals 11. So that moved one thing over to the left side, and now I'm going to move the second thing over to the left side. Minus 11 on both sides. That gives me 9b squared minus 8b minus 11 equals 0, which is standard form, where a is 9, b is -8, and c is -11. And now I can plug all of those into my quadratic formula. So -b, where b is already a negative number, it's going to be -8, which I'm going to change into +8, plus or minus the square root of b squared minus 4ac, all divided by 2a. Everything inside of that square root symbol, or the discriminant, should happen first. So 8 plus or minus the square root of, actually let's simplify that outside of there, 64 minus, I'm going to get a negative number. 4 times 9 times 11 is 396. 64 minus 396 is negative 332. Divided by, I'm going to simplify the bottom, but it's actually not going to matter. I have a negative sign inside that square root symbol. I'm actually pretty much done with the problem already. I just have to understand what that really means. So if I'm trying to take the square root of a negative number, I actually can't do that yet. Without using imaginary numbers, I can't actually do that. So I'm really just going to write that I have no real solutions. All right, you are not going to write that you have no solution. So on our previous set of notes, I actually made a mistake. When we were looking at those graphs, I said that we have no solution, and that's really not complete. We have no real solutions. There are solutions that exist, they're just imaginary. So I just want to make that distinction, that we have no real solutions to this quadratic. There is no real number that we can plug in to make that equal to 0, because it doesn't actually hit the x-axis. All right, on number 5, I have that in standard form already. So I'm going to plug in my A, B, and C of 4, 9, and negative 63 into negative B plus or minus B squared is going to be 81. I'm going to start doing this a little bit quicker. I'm going to simplify the steps that I know happen first. Minus 4 AC all over 2A or 8. So 4 times 4 times 63 would give me 1,008. I have a negative 4 times a positive 4 times a negative 63. That is going to turn into a positive 1,008 or plus 1,008. And I'm going to add that 81 into it. I'm going to do the square root of 1,089, which gives me 33. So this is really just doing this step. Finding the square root of that number gives me 33. So negative 9 plus or minus 33, all divided by 8. And now I'm going to split this into 2 separate problems, negative 9 plus 33 over 8, and negative 9 minus 33 over 8. So that gives me 24 over 8, or 3. And this gives me negative 42 over 8, which is going to be a fraction. You can simplify that as a fraction, or if you want to write it as a decimal, that's okay too. I'm going to simplify that. I guess let's just do it as a fraction. Negative 21 over 4. So I divided the top and the bottom both by 2. And that's my solution set. Negative 21 over 4 and a positive 3. Last one I'm going to do, we want to bring that all to one side. So I'm going to have 8x squared minus 7x minus 7 equals 0. I am running out of time, so I'm going to do this real quick. I'm going to plug all those into my quadratic formula. That's going to change from a negative 7 into a positive 7. Negative 7 squared is 49 times 4ac all over 2a. So I'm going to multiply negative 4 times 8 times negative 7. That gives me 224, and the square root of 224 is an irrational number. So 7 plus or minus 14.967. That goes on forever, but I'm going to actually just round that to 14.97. I'm going to add and subtract that from 7. 7 plus 14.97 divided by 16, and 7 minus 14.97 divided by 16. So 7 plus 14.97 divided by 16 gives me a rounded answer of 1.37. And 7 minus 14.97, again, this answer is rounded, divided by 16 gives me negative 0.498. Those two numbers make my solution set.